About the PN junction diode. PN junction diode forward bias as well as in the reverse bias region. So firstly I'll explain what is a PN junction diode. For that, a pure form of semiconductor material is taken and one side is doped with trivalent atoms and another side is doped with pentavalent atoms. We'll get the PN junction diode. So in P side, holes are the majority charge carriers and electrons are the minority charge carriers. As well as in the N side, electrons are the majority charge carriers, holes are the minority charge carriers. Therefore, across the junction, there is a probability of free electrons to diffuse over towards the P side. Similarly, free holes will move towards the N side. As the free electrons moves across the junction from N side to P side, then the donor ions will become positively charged. Similarly, the holes will cross the junction and the acceptor ions will become negatively charged. So, as a result, a negative charge is established across the P side and a positive charge is established across the N side. So, due to this, the electrons will not cross this junction towards the P side. Similarly, hole will not cross the junction towards the N side because of this potential barrier. And the value of this potential barrier is 0.2 volts for germanium and 0.6 volts for silicon. As well as we are not applying any voltage to this PN diode, that is at open circuited conditions, the electric field will be existing across this junction. Due to this, the voltage available across the junction is 0.2 volts for germanium material as well as 0.6 volts for silicon material, and these values are depending upon the temperature. And now I'll discuss about the forward bias region. For that forward bias region, if P side is connected to positive terminal of the battery and N side is connected to negative terminal of the battery, that is, anode is connected to positive terminal of the battery and cathode is connected to negative terminal of the battery, then the diode is said to be in the forward bias region. I'll explain the working of this one when it is in the forward bias region. As the holes are having positive charge and the potential what we are giving, that is also a positive charge, will be repelled and will cross the junction, and the applied voltage should be greater than the cut-in voltage, then only the hole will cross the junction. Similarly, towards the N side, all the electrons will repel each other and will cross the junction towards the P side. So, constitute current, and that current, the magnitude of current will depends upon the applied voltage V, and the depletion region width will be reduced. This is the first point we have to observe. Width will be reduced, and second point, maximum current will be flowing through the circuit and the resistance offered by that material will be reduced, that is minimum. So, when the diode is in the forward bias region, these are the 3 points we will observe. Now, when the diode is in the reverse bias region, so what is the reverse bias region? When anode of the material is connected to negative terminal of the battery and cathode is connected to positive terminal of the battery, then the diode is said to be in the reverse bias region. In this case, all the holes will be attracted towards this negative terminal, and towards the N side, all the holes, electrons will be attracted towards the positive terminal. So, in this case, what are the points we are observing? The depletion region or width will be increased and the current flowing through this diode will be reduced, that is minimum current is flowing. How this minimum current will flow towards this circuit, as well as the majority carriers are not in the conduction part, so this current is due to minority charge carriers which are there in the P side and N side. So that current is called the reverse saturation current. That is very small, it is I is very minimum when it is in the reverse bias region, reverse saturation current I0, and the resistance offered by this diode will be maximum, R is maximum. And the diode current equation is I is equal to I0 into e power V by eta Vt minus 1, as I is the diode current, I0 is a reverse saturation current in microamperes, and V is the applied voltage, and Vt is the thermal voltage, and at room temperature the value of Vt is 25 millivolts or 26 millivolts, and the value of eta is constant, and it is 1 for germanium and 2 for silicon.